Hey there again. If it is as late where you are right now as it is where I am, you should probably just go to bed, work on this again tomorrow, but I'm going to math it up. Ah! Yeah, I hit the wrong button there. Whoops. All right. Exponents Assignment 3. And this is exponent law. So we're not actually solving, we're simplifying today. So stick with that simplifying. Okay. So question 1A. The first is the multiplication law of exponents. So when you multiply two bases that are the same, you add their exponents together, and that's simplified. So for the example A, our bases are the same, 3. So we can simply just add the exponents on top. Add the exponents. So this is going to be equivalent to 3 to the power of 4. 2 plus 2, 4. So simple. 3 to the power of 4. 1b. Once again, bases are the same. This one has an invisible exponent 1. Got to keep that in mind. Invisible exponent 1. So this is going to be equivalent to 2 to the power of 3. 2 plus 1. Where's that 1? There it is, right there. 1c. Once again, same thing, the same base. 4, 4. That has an invisible exponent 1. Keep that in mind. You want to make sure you understand that, because otherwise you're not going to get the right answer. It has the same base, exponent 3. There's 3 of them in total. 1 to the power of 2, 1 to the power of 1. 2 plus 1 is 3. Now, there's 3 of them. 1D is 3, but it's not any more difficult. We got 1, 2, 3. 3 bases, they're all the same, so our base is going to be 6. And we have 4, 2, and 4. That's going to add up to 10. 6, exponent 10. We've simplified that expression. So 6 to the 4th plus 6 to the 2nd plus 6 to the 4th is 6 to the 10th. E. Once again, this 4 is going to be the power of 1. All of them have the same base, so that means we can simply use the multiplication law of exponents, and we just add them together. This is going to be equal to 4 to the power of 7. Last one is 1f. Same thing, this is 3 to the power of 1. Keep that in mind. The bases are all the same, so we can simply just add the exponents together. This is going to be, it's like simple math here. This is 3 to the power of 8. There it is. We've simplified that expression. The next exponent law is division law. And if you would think what we are going to do here, what's the difference between multiplication and division? Multiplication law, you add them together, add the exponents together, and division law, that's right, you subtract the exponents. So for this one, 2a, once again, this is pretend we have an exponent to the power of 1 here, 3 to the power of 1. What's 2? Let's drop my highlighter here. What's 2 minus 1? 1. And how do we write 3 to the power of 1? We just write 3. Right? We don't write to 3 to the power of 1 because we don't need to. It's just 3. 2b, 4 to the power of 4 divided by 4 to the power of 2. Now, I'm sure your teacher has gone over how you could expand on this and cancel out. But again, we just simply subtract the exponents from one another, giving us an answer of 4 to the power of 2. I'll rewrite that 2 because I don't like it. 4 to the power of 2. Right? 4 minus 2 is 2. 4 to the power of 2. C. 5 to the 4th minus 5 to the 3rd. Looking at the exponents again, the bases are the same, so we can just look at the exponents, and we can simply subtract the exponents. This is going to be equal to saying 5. It's going to be simplified that expression. 5. 10 to the 4 divided by 10 to the power of 1. Now, once again, the division law states you just subtract the exponents when the base is the same and you're dividing. So this is going to be equal to 10 to the 3rd. 4 minus 1, 3. Once again, bases are the same. This is going to be equal to 12 to the power of 2. 6 minus 4, 2. F. Bases are the same. They're going to be the same all worksheet. We're practicing 6 to the 5, 6 to the 3, 6 to the 5th divided by 6 to the 3rd. Division law is going to tell you once again, you just subtract exponents. So this is going to be equal to 6 to the power of 2. Pretty straightforward so far. All you got to do. Now this next one, this is the power of a power law. And you can already think everything inside that bracket is going to be multiplied by it, is going to be squared. So 3 to the power of 3 times 3 to the power of 3. The base is 3, and we were to write that out, you just see 3 to the power of 6. Right? 3 times 3 times 3 times 3 times 3 times 3. Your teacher will show you. Maybe I'll go through this. So 3 to the power of 3, right? 3 to the power of 3 times 3 to the power of 3. This is what the square would do, right? It would square whatever's in the bracket. And if you were to expand on those, you'd get 3 times 3 times 3. And then over here, 3 times 3 times 3. And if you remember our last worksheets, that's like writing 3 to the 6th. So it's like you've multiplied 3 times 2. That's what power to the power law is. Power of a power law. Now, this is equivalent to 3 to the power of 6, which is 3 times 2. 3 to the power of 6. Super simple, as long as you know what you're doing and why it works. Now, this is equivalent. 2 is the base, and it's also to the power of 6, because 2 times 3. This is 3c. Now we have the base is 5, so this is going to be equivalent to 5 to the power of 4, because the exponent 5 squared to the power of 2. 5 to the power of 2 to the power of 2. So we're squaring everything inside the bracket. 5 to the power of 4. Numbers are getting a little bit bigger, but I think you can handle this. 4 to the power of 4. And then everything brought to the power of 2. Simply multiply the exponents. And this is going to be equal to 4 to the power of 8. Not too difficult so far, right? Kind of nice. Obviously, I'm using numeric bases, but don't solve these. Just simplify the terms. All right. What do we got? We have 3e. Now, 3e is going to be equivalent to, or simplified to, 3 to the power of 5 to the power of 9. Not too difficult. 5 to the power of 9. and 3f. Once again, this is the biggest one we've done so far, but it's only 3 times 4. This is equivalent to the base of 6 brought to the 12th power, because it's the 2 exponents multiplied. It's to the power law. Power of a power law. It's not too difficult. All right, let's go to the next one. Now, need to pay attention to some subtleties when we start getting negative and positive exponents mixed together. Remember, we're adding exponents. Multiplication law states that you add the exponents together to simplify the expression. Now, we're adding integers, -2 and 3, negative numbers. So when you do this, we're going to be left with -2 plus 3, which is going to be +1. So this is just 5. It's not 5 to the power of 5 because it's a 2 and a 3. 1's a -2. Now, this next one, same example, a -3 to the power 3 to the power of -3, 3 to the power of -3, and 3 to the power of +5. So this time it's going to be equivalent to the base of 3 brought to the power of 2. The difference between -3 and 5 is going to be left with 2 exponents left. 2 to the power of 2, 2 multiplications of 3 left. I'm not sure if I used the right words there. All right. Once again, 3 to the power of 3 times 3 to the power of -2. This is going to leave us with 3 to the power of 1. +1, but we don't write the 1, so it's just 3. Now, let's go to the next questions. Now, this might seem a little bit different, but really it's not. It's negative bases, and there'll also be some negative exponents as well. When you multiply these two together, you're going to still be same base. The base is going to be -4. And when you're using the multiplication of exponents law, you're going to add the exponents. So this is going to be -4 to the power of 8. Once again, now we have negative exponents and a negative base, but keep the base the same, nothing happens with it. And you're going to simply add the exponents together, and you're going to get +2, -3 plus 5, +2. So you're getting -10 squared. The last one, we got 3 here, a positive, a negative, and a positive. And our base is going to stay the same, -9. And we have 7 minus 2. Right, so I'm going these two together. That's 7. And then I'm taking away this one, which is 5. -9 in parentheses to the power of 5 is our simplified expression. Okay. Same idea, but now it's division law with negative exponents. So it's the fact that when you're dividing bases that are the same, that have exponents, you just subtract the exponents. So what we're going to do is we're going to say 4 to the 3 minus 4 to the 2 is just going to be equal to 4 to the 1, but you don't write 4 to the 1, you just write 4. Next, we want to go over to 5b. 10 to the 4 and 10 to the 2. 4b is 10 to the 4 minus 10 to the 2. It's not minus, divided by 10 to the 2, but again, just subtract the exponents. Keep the same base, 10 to the power of 2. That's our answer, 10 to the power of 2. And C, 5 to the 5. This is going to be equal to 5 to the power of 2. 5 minus 3 is 2. 2 remaining. 5 squared is our answer. Now we have some interesting negative exponents mixed in. 10 to the power of 4 divided by 10 to the power of negative 3. So what do we do here? Once again, think about your integer rules. If I'm subtracting a negative, it's like I'm adding a positive. I'm going to it's like I'm adding 3. It's going to be equivalent to 10 to the power of 7. Right? Divide. So you're dividing by a negative 10 to the power of negative 3. So it's going to be equivalent to 10 to the power of 7. Now, let's look at this one. Okay. So I'm keeping my same base. It's a positive base, 3. Negative 5 divided by 3 to the negative 7. Division law states you're going to subtract the exponent from the numerator. Sorry, subtract the exponent from the denominator from the exponent of the numerator. And this is going to leave us with 3 to the power of 2. Negative 5 minus negative 7, positive 2. F. And this one is going to be same base of 2. And we've already discussed which way we're moving on the number line. Subtracting a negative is like adding a positive, and we're moving it positive 7. Okay. Power of a power law. And we're doing multiplying our exponents together, but we're also going to throw some negative exponents in here. Power of a power law. So this is equal to 6 to the power of 3 times 2, which is 6, right? 6 to the power of 3 times 2, which is 6. Now, this is going to be equal to our base of 4. The base stays the same. Negative 2 times negative 2. 4 to the power of negative 2 raised to the power of negative 2. The two negatives, when they multiply together, they're going to equal a positive. 4 to the power of positive 4. Now, 7 to the power of 2 is actually going to be equal to, when we multiply it, same base, 7 to the power of 2 multiplied by negative 4. This is going to be to the power of negative 8. Yeah, it's a little bit different. We got a negative exponent as an answer. We're going to get some more of that. D, 8 to the power of negative 4. Our base will stay the same as it always has this whole time, but what will change is we're going to get a negative exponent because it's a negative times a positive, and it's going to be 8 to the power of negative 12. That's our answer. Next one. Oh, negative times a negative, right? We're multiplying our exponents here, and they're both negative, so let's keep our base the same. And we're going to get a positive 6, 2 to the power of 6. 2 times 3, and negative 2 times negative 3, positive 6. Last one here, cruising through this stuff. F, 5 to the 4th power multiplied by negative 2, or exponent negative 2. So this is going to keep our same base to the power of 5. We're going to multiply 4 by negative 2, which gives us negative 8, 5 to the power of negative 8, and that is a really small number. All right, now we got these last handful of questions that are a mixture of everything we've seen so far. and you got to figure out what rule you're using. The first one, 7a. Now this is a negative 8 to the power of 6 divided by 8 to the power of 4. This is the division rule, division law. And when you're dividing numbers with the exponentiation that have the same base, you subtract the exponents. So this is going to be equal to 8 to the power of, no, not 4, 8 to the power of 2. All right, this is power of a power law. This is going to be equal to, interesting. This should have double brackets here and then there. Okay, I'll fix that. Now, what you'll do is, again, multiply the parentheses, everything inside the parentheses by the exponent outside. So we're going to be, the answer will be negative 4 to the power of 9. 3 times 3. Now, the next one, we are doing the multiplication law. So this is going to mean that we we add the exponents together if they have the same base. So they do have the same base of 2, and we are going to add the exponents. 4 plus negative 2 equals 2 to the power of 2. 3 more. Ooh, it's a triple. So we have 1, 2, 3. And we are 1 through 3 negatives. Oh, negative 2, negative 2, negative 4. So we're going to add these negatives together. Our answer is going to be same base is negative 6 to the power of negative 8. Negative 2 plus negative 2 is negative 4 plus negative 6, negative 8. Negative 6 to the power of negative 8. And the next one is 4/5 to the power, 4 to the power of 5 divided by 4 to the power of negative 7. This is the division law, and we're going to use integers to add these two numbers. When you subtract these two numbers, you're subtracting the exponents, and we're going to get an equivalent answer of 4 to the power of 12. I almost said negative 12 for some reason. 12. F. 7. Their answer is the base is always going to be the base. We're simplifying. We're going to multiply. This is the power of a power law. Multiplying negative 2 and negative 4. The two exponents. This is going to give us an answer 7 to the power of 8. And this might have seemed complicated when you first looked at it, but really all I want is to do the laws and simplify the expressions. So I hope that wasn't too bad. Thanks for mathing it up.